Download this code from codegive.com, link in the description below. Deep File Analysis with Microsoft Defender for Endpoint, a comprehensive tutorial. Microsoft Defender for Endpoint, formerly Microsoft Defender Advanced Threat Protection or mdatp, is a robust endpoint detection and response (EDR) solution designed to protect organizations from advanced cyber threats. One of its most powerful features is deep file analysis, which allows you to proactively investigate suspicious files, understand their behavior, and identify potential threats before they can impact your environment. This tutorial will guide you through understanding deep file analysis, its workflow, practical applications, and provide code examples to leverage its capabilities programmatically. Understanding deep file analysis. Deep file analysis, DFA, is a cloud-powered detonation service that analyzes potentially malicious files in a safe and isolated environment, a sandbox. It goes beyond traditional signature-based detection methods by executing the file, observing its runtime behavior, and generating a detailed report that helps security analysts understand the file's intentions. Key features and benefits of DFA ** dynamic analysis * executes the file in a controlled environment to observe its runtime behavior, revealing hidden malicious activities that static analysis might miss. Comprehensive reporting * provides detailed reports with indicators of compromise, IOCs, file modifications, registry changes, network connections, process creation, and other relevant information. Automated analysis automates the analysis process, freeing up security analysts' time and resources to focus on more complex threats. Integration with Defender for Endpoint seamlessly integrates with the Defender for Endpoint platform, allowing you to trigger DFA directly from alerts, incidents, or threat hunting queries. Cloud-powered leverages the scalability and processing power of the Azure cloud, enabling fast and efficient analysis of large files. Machine learning and behavioral analysis employs advanced machine learning algorithms and behavioral analysis techniques to identify suspicious activities. Multiple operating systems supports analysis of files targeting various operating systems, including Windows, Mac OS, and Linux. Note: Linux support might be more limited and require specific configuration. Centralized management provides a centralized console for managing and monitoring DFA jobs, viewing reports, and configuring settings. 2. How deep file analysis works, the workflow. The typical deep file analysis workflow involves the following steps. 1. File submission ** A file is identified as potentially malicious, either through automated alerts, threat hunting investigations, or manual submission by a security analyst. 2. File hashing ** The file is hashed, example SHA-256, to uniquely identify it. If the file has been previously analyzed, Defender for Endpoint will retrieve the existing report. This significantly speeds up subsequent analysis of the same file. 3. Sandboxing ** The file is securely uploaded to a cloud-based sandbox environment. The environment is designed to emulate a typical endpoint system, including operating system, installed applications, and network connectivity. 4. Execution and monitoring ** The file is executed within the sandbox. Defender for Endpoint monitors its behavior closely, tracking file system changes, registry modifications, network connections, process creations, and other relevant activities. 5. Analysis and reporting ** After the execution phase, the collected data is analyzed by Defender for Endpoint's engine. The analysis identifies suspicious activities, such as malware installation, data exfiltration, or command and control communication. A detailed report is generated, including Asterisk summary asterisk an overview of the file's behavior and overall assessment, malicious, suspicious, benign. Asterisk indicators of compromise, IOCs hashes, file paths, registry keys, network addresses, and other indicators that can be used to identify the file on other systems. Asterisk process tree asterisk a visual representation of the processes created by the file, showing parent-child relationships. Asterisk file system activity asterisk a list of files created, modified, or deleted by the file. Asterisk registry activity asterisk a list of registry keys created, modified, or deleted by the file. Asterisk network activity asterisk a list of network connections made by the file, including IP addresses, ports, and protocols. Asterisk behavioral analysis asterisk a description of the file's behavior and how it deviates from normal activity. Asterisk machine learning verdict asterisk the ML verdict on whether the file is considered malicious. 6. Report review and remediation asterisk security analysts review the DFA report to understand the file's behavior and determine the appropriate remediation actions. This might involve blocking the file, quarantining affected systems, or investigating related incidents. 7. Intelligence sharing, optional. The findings from the DFA can be shared with Microsoft's Threat Intelligence Network and potentially with other organizations, contributing to the global cybersecurity ecosystem. 3. Triggering deep file analysis. There are several ways to trigger deep file analysis in Defender for Endpoint. Asterisk automatic submission asterisk configure Defender for Endpoint to automatically submit suspicious files for analysis. This is often based on detection alerts or behavioral patterns. Asterisk manual submission from the Defender for Endpoint portal asterisk select a file from an alert or incident and choose the deep analysis option. Asterisk using the Microsoft Defender for Endpoint API, programmatically. This is the method we'll focus on with code examples, allowing you to automate DFA submissions and retrieve results. 4. Prerequisites. Before you start using the API, ensure you have the following. 1. Microsoft Defender for Endpoint license asterisk you need a valid license for Defender for Endpoint. 2. Azure Active Directory, Azure AD, application asterisk create an Azure AD application with the necessary permissions to access the Defender for Endpoint API. 3. API permissions asterisk grant the Azure AD application the appropriate API permissions in Defender for Endpoint. 4. PowerShell, or other scripting language. You will use PowerShell, or Python, etc., to interact with the API. 5. Authentication credentials asterisk you will need the application ID, tenant ID, and client secret, or certificate, for your Azure AD application. V. Setting up the Azure AD application. 1. Register an application in Azure AD asterisk. Asterisk sign in to the Azure portal, https://portal.azure.com, https://portal.azure.com. Asterisk navigate to Azure Active Directory app registrations new registration. Asterisk enter a name for your application, example Defender.pdfa. Asterisk choose the account type, accounts in this organizational directory only, unless you have a specific reason to choose another option. Asterisk leave the redirect URI blank. Asterisk click register. 2. Configure API permissions asterisk. Asterisk in the Azure AD application, go to API permissions, add a permission. Asterisk select Microsoft Graph. Asterisk choose application permissions. Asterisk search for and select the following permissions, and potentially others, depending on your use case. Asterisk threat intelligence.readwrite.all, for submitting files and retrieving reports. Asterisk threat intelligence.read.all, Alternative if you only need to read the DFA reports. Security events.read.all might be necessary for correlating DFA results with other security events. Click add permissions. Click grant admin consent for your tenant name. This is crucial for the application to have the permissions. 3. Create a client secret, if using client secret authentication. In the Azure AD application, go to Certificates and Secrets, New Client Secret. Enter a description and expiration date. Click Add. Important copy the value of the client secret immediately and store it securely. You won't be able to retrieve it again. 4. Note the application ID, client ID, and tenant ID. In the Azure AD Applications Overview blade, copy the application, client, ID and the directory, tenant, ID. 6. Code example, PowerShell script for deep file analysis. This PowerShell script demonstrates how to authenticate with the Defender for Endpoint API using an Azure AD application, client secret authentication. Submit a file for deep file analysis. Check the status of the analysis. Retrieve the deep file analysis report. Explanation *. 1. Configuration *. $tenant ID, $client ID, $client secret, replace these with the values from your Azure AD application. $mdatp URL, the base URL for the Defender for Endpoint API, usually doesn't need to be changed. $file path, the path to the file you want to analyze. Important, be extremely careful when choosing which files to analyze. Only analyze files that you strongly suspect are malicious, and do so in a highly controlled environment. 2. Authentication *. The script uses the client credentials grant flow to obtain an access token from Azure AD. This token is used to authenticate subsequent API requests. Invoke REST method makes the HTTP request to the Azure AD token endpoint. 3. Submitting the file for analysis $submit URL, the API endpoint for submitting a file for detonation. The file content is read into a byte array and then converted to a base 64 string. This is necessary for transmitting the file content over the API. Convert.json creates a JSON payload for the API request, including the file name, optional, and the base 64 encoded file content. Invoke REST method sends the file submission request to the Defender for Endpoint API. The $detonation ID is extracted from the response. This ID is used to track the analysis progress and retrieve the report. 4. Checking analysis status and retrieving the report *. Get analysis status function. Queries the API to get the current status of the analysis, given the $detonation ID. Possible status values include queued, in progress, completed, error, timeout. Get analysis report function. Retrieves the full analysis report as a JSON object. The script polls the analysis status every 30 seconds, you can adjust this, until the analysis is completed, has failed, or a timeout is reached. If the analysis is successful, the script retrieves the report and extracts some key information, verdict, confidence, MITRE ATT and CK techniques, number of IOCs. The full report is also optionally saved to a JSON file for further analysis. 7. Important considerations and best practices. File selection. Exercise extreme caution when selecting files for deep file analysis. Only submit files that you genuinely suspect are malicious. Analyzing benign files can waste resources and potentially trigger false positives. Data security. Be aware that submitted files will be uploaded to Microsoft's cloud environment for analysis. Ensure that you comply with your organization's data security and privacy policies before submitting any files. Avoid submitting files that contain sensitive or confidential information unless absolutely necessary. Rate limiting. The Defender for Endpoint API has rate limits to prevent abuse. Be mindful of these limits and implement appropriate error handling in your scripts. Check the Microsoft documentation for current rate limit information. Error handling. The PowerShell script includes basic error handling, but you should implement more robust error handling for production environments. Alternative authentication methods. While this example uses client secret authentication, using certificate-based authentication is generally more secure. Automated submission configuration. Carefully configure automated file submission policies to minimize the risk of submitting benign files. Use a combination of rules based on file type, size, reputation, and behavioral patterns. Report analysis. Thoroughly review the DFA reports to understand the file's behavior and identify potential threats. Pay attention to the IOCs, process tree, network activity, and other relevant information. Remediation. Take appropriate remediation actions based on the DFA report findings. This might involve blocking the file, quarantining affected systems, or investigating related incidents. Stay updated. Keep your Defender for Endpoint agents and security definitions up to date to ensure the best protection against the latest threats. Regularly review the Defender for Endpoint documentation for updates and new features. Hunting and correlation. Use the IOCs and other information from the DFA reports to proactively hunt for related threats in your environment. Correlate DFA results with other security events and logs to gain a more comprehensive understanding of the attack. 8. Python example, alternative. Here's a similar example using Python, which might be preferred in some environments. Key improvements in the Python example. Error handling. More robust error handling with try, except blocks and response. Raise _for _status, to catch HTTP errors. File handling. Uses with open, for safer file handling, ensures the file is closed properly. Requests library. Uses the requests library, a standard and more user-friendly way to make HTTP requests in Python. JSON handling. Uses the JSON module for encoding and decoding JSON data. Includes indentation for better readability in the saved JSON file. Handles missing values. The example retrieves the MITRE techniques report using .get, MITRE techniques, n/a, accounting for the possibility that the value is not present and preventing errors. 9. Conclusion. Deep file analysis is a valuable tool in Defender for Endpoint for investigating potentially malicious files and proactively identifying threats. By understanding its workflow, using the API, and following best practices, you can enhance your organization's security posture and better protect your endpoints. Remember to handle file submissions with care, stay updated on the latest threats, and integrate DFA results into your broader threat intelligence and incident response processes. Always prioritize secure credential management and adhere to least privilege principles when configuring your Azure AD application and API permissions.